In this video I'm going to look at a Leaving Cert Pass paper question from 2020, paper 2, question 1 on coordinate geometry of the line. You are given 3 points and you're first asked to find the perpendicular distance from a point A to BC. First of all, we need to know what the equation of BC is. The formula for the equation of the line is y minus y1 equals m times x minus x1, where x1 and y1 are a point, either B or C, and m is the slope of BC. So let's work out the slope of BC. Well, the slope is given by the formula m equals to y2 minus y1 over x2 minus x1. So that's the change in the y's over the change in the x's. So we'll go 3, which is y2, minus the y value of b, which is minus 12. So 3 minus minus 12, so that's 3 plus 12, over minus 4 minus 6. So that's 15 over minus 10, which gives us a slope of minus 3 over 2 there. So we know on going from B to C, that line is declining. Okay, so it's got a negative slope. That's our slope. So we just need to plug that in and either of the points B or C into the equation of the line, and we'll get the equation of BC. So BC will be y minus y1, so we'll just choose the point C to go with. So it's y minus 3 is equal to our slope, which is minus 3 over 2, times x minus the x value of C, which is minus 4. So it's x minus minus 4, which is x plus 4. So we get rid of the fractions, multiply everything by 2, that's 2y minus 2 times 3, which is 6, is equal to, now we expand in the brackets here, minus 3x minus 12, because minus 3 by 4 is 12. Now we'll just take everything over to the one side and keep the x positive, and that gives us 3x plus 2y minus 6 plus 12, which is plus 6, equal to 0. And that is the equation of BC. So you're asked to find the perpendicular distance between A and BC. For that we need the formula in the tables, and I'll just put that in now. If our line BC is 3x plus 2y plus 6 equals to 0, our perpendicular distance is going to be A, which is the coefficient of x in the line, times x1, which is the x value of your point. So it'll be x value of A. So A here is a point 2 minus 6. So plugging in the formula, we will get 3 times 2 plus 2, which is the coefficient of y in my line, times the y value of the point, which is minus 6, plus 6, which is the constant in the line, and it's the modulus of that, so it's the positive value of that, all over root a squared plus b squared. So that's going to be 3 squared plus 2 squared, which is 3 times 2 is 6, minus 12, which is minus 6 plus 6, so that's 0, over root 13. That doesn't really matter because 0 over anything is just 0. So the distance between A and the line BC is 0. That just means there is no distance, so A must be on the line BC. So the conclusion, A, B, C are co-linear. Okay, so now we're going to look at the next question. You've got a diagram with 2 lines, A and B. So we've got A and we've got B, and we're probably asked to find theta here, which is the angle in between those 2 lines. Find the value of theta and correct it 3 decimal places. Okay, let's have a look at a few things that we do know. There is a formula in the tables to find out the angles in between 2 lines when you know the slope of the lines. Now the slope just tells you the direction that they're going, so the slope always tells you the difference in the y values compared to the difference in the x. So I'm able to use the fact that B has a slope of 60 degrees with the positive sense of the x-axis. So what I could do is work out the slope of B from that, because if that's B, and I just zoom in, if I make a triangle there, how does y change with respect to x on the line B? Well, the tan of 60 degrees is equal to y over x, which is the slope of b, which is, if I look up tan of 60 degrees, that's root 3, or root 3 over 1. So therefore the slope of b is root 3. You can just rearrange the equation of a to isolate y. The slope of a, if I rearrange that equation, isolate y, so I leave y on its own, you get 2y equals x plus 1, y equals a half x plus a half. So the slope of a is a coefficient of x there, which is a half. Okay, so we could actually plug that into a formula, and the tan of the angle in between the two lines would be plus or minus m1 minus m2 over 1 plus m1 times m2. So if I just plugged in those numbers, I'd be able to work out the tan of theta, okay, and then I'll be able to get the inverse tan of that number to find out what theta is. So if I just do that, it'll be plus or minus 1, we'll say root 3, okay, the line on top, root 3 minus a half over 1 plus a half times root 3, which is root 3 over 2. Just tidy that up. That's equal to plus or minus twice root 3 minus 1 over 2 plus root 3. If you wanted to tidy it up, you could put that into your calculator, or else you could just multiply above and below by the conjugate. Remember, when you're dealing with thirds, multiply above and below by the conjugate of your denominator, and which is essentially just 1, because it's the same number over the same number, and you're able to tidy that all up, and you get rid of the surds down below, and that gives you a figure of twice root 3 times 2, which is 4 root 3, twice root 3 times minus root 3 gives you a figure of minus 2 times 3, which is 6. Then you got minus 1 times 2, which is minus 2, and minus 1 times minus root 3, which is plus root 3. Bottom will just tidy up to 2 times 2, which is 4, plus 2 times minus root 3, which is minus 2 root 3, plus root 3 times 2, which is plus 2 root 3, and root 3 by minus root 3, which is minus 3. So that's equal to, if I tidy all that up, plus or minus minus 8 plus 5 root 3. That's what tan of theta is equal to. And we plug that into the calculator, what you're going to find is theta is equal to 33.435 degrees. So there is another way to do this. If I create a line, which I've done there in blue, and if I say this angle, and this angle, well, all of them should be 180 degrees. This is a line that's perpendicular to the y-axis, so this is parallel to the x-axis. So that orange one is 120, okay, because that's 120. If this is 6, okay. This angle here, if the slope of that angle is a half, that means that ratio is 1:2. Okay, so inverse tan of a half tells me what that angle in pink is. Inverse tan of a half is equal to 26.565 degrees. So 120 plus 26.565 plus theta should give me 180 degrees. So theta then must be equal to 180 minus 120 minus 26.565, which is 33.435 degrees. Just another way of looking at it.